Hello and welcome to part 7 of Dev Maths and Stats Refresher Course Lecture 2. In this video we're looking at the quotient rule. This is for when you have a function which is two other functions divided. Now this is almost optional because when you have a situation where y is equal to two functions u divided by v, you can always see this as u times 1 over v. And here you can apply the product rule, so it's this times this using product rule. But if you can't differentiate that, that would be difficult. But you can always get around it. You can use the chain rule as well. So you can use this rule, product rule, but often it's easier to use the quotient rule for this divided by this. So it's worth knowing. So back to Maple and into the quotient rule. So this rule just says that if y is the quotient of u over v, if y is the quotient of u and v, so that y is equal to u divided by v, if u and v are both functions of x, then to get the overall derivative you do this, which looks complicated, but when you break it down, the top part in brackets here is really just very similar to the product rule, except here you have a minus instead of plus. And then when you have finished doing this, then you divide by v squared. So it's not actually that bad. So let's do one example here as typed, which is y is equal to e to the power x divided by 5x squared. So you can imagine that looks like this. So u is e to the x and v is 5x squared. So if you go through the rule bit by bit, it says, as before, you differentiate this, so you have e to the x, leave this unchanged. So you have 5x squared e to the x, so that's that. Then you leave this alone and differentiate this, so you have 10x times e to the x, that's this part. But the difference is here you have to put in a negative sign as well from here. So it's important to do this in the right order and put in the negative sign. So that's similar to the product rule with the negative sign, but then what's not similar is that after doing this you divide by v squared. So 5x squared is 25x to the power 4, so you get this on the bottom. And now you've finished. And in this example you could simplify this further to here. So now let's look at these examples. Let's take the first one to the whiteboard. Please feel free to fast forward, but make sure you try this for yourself and then ask me if you're at all unsure. Y is equal to log of x divided by x to the power 3. So log x divided by x to the power 3. So here u is the log x and v is the x to the power 3. Then differentiate these. And then you can assemble the final result. So y dashed has got to be this one differentiated times this one left alone. That's 1 over x times x to the power 3. And then this one left alone and this one differentiated. So I'd write it in this order, 3x squared, this one differentiated times log x. That's the same as the product rule, but one of the differences is that here we have to put a negative. The other difference is that when we finish this, we divide by v squared, which is this one squared, so x to the power 3 squared, because we're applying this rule here, divided by v squared. So that's differentiated completed, but we should simplify a little. So here we have x cubed divided by x is x squared minus 3x squared log x But all of that needs to be divided by x cubed to the power 2 is x cubed times x cubed is x to the power 6. So the final answer is x to the power 2 divided by x to the power 6 is x to the power 4. Similarly here, so we've got 1 minus 3 log x all divided by x to the power 4. And hopefully we get something like that here. Okay, so Maple has split this, it's the same answer, Maple split into 2 parts. Okay, 2 more examples of this before we go on to mixed examples. So we have here y is equal to 12w to the power 4 times e to the minus w. Okay, let's write that. Usually you would write this like this one. 12w power 4, 12w to the power 4 times e to the minus w. Now, you could use here the product rule, this times this. Here you would have to use the chain rule to do this one, because we have not got a rule for this yet, so it's the chain rule. Or, this is the same as 12w to the power 4 divided by e to the power w. So this is the same, because to the power negative w is 1 over to the power w. So here we can use quotient rule. So I'd say that u is equal to 12 w to the power 4, b is equal to e to the power w, so the derivatives are like this. Oh, wow. Amazing. 48, and b dashed is equal to e to the power w. Okay, that's better. Let's now assemble the answer, which is y dashed is going to be equal to this one differentiated times this one left alone. So 48 w to the power 3 e to the power w. Okay. And then this one left alone and this one differentiated. So 12 w power 4 e to the power w. Because it's quotient rule, we have to remember 2 things. The negative here and the divide by v squared, which is e to the power w squared. So it looks very difficult at this point. Just check that we're on the right track. This times this, yes, and this times this, yes, with a minus sign. So now we can slightly simplify, because e to the power w squared is e to the power w times e to the power w is e to the power 2w. So this is all divided by e to the power 2w. Okay. So e to the power w here, e to the power w here, and e to the power 2w here equal means that we can cancel. You can also take out the common factor of 12 and w. So you'd have 12 coming out here, w to the power 3 coming out here, and you're left here with 4. Oops, that's it. And here you're left with negative w. And on the bottom we have e to the power w. Because w, this brings it down to here, cancels that out. 12w cubed gives you the 48 w cubes, and 12 gives you the minus 12w to the power 4 there. So hopefully Maple will give you some answer a bit like this. Let's have a look. Yeah, I just didn't factorize it. and e to the power minus w is this back in this kind of form here. That's the same. So that brings us to the last example. Just copy this. So here. And here we're looking at it's e to the power a divided by log base e of a. So in the product rule we had an example of e times log, and now we have e divided by log. So clearly u is e to the power a and v is log a. So looking at the derivatives, you've got e to the power a and 1 over a. Then constructing this, we have this differentiated times this left the same, e to the a log a, minus, because it's product the quotient rule, this left the same times this differentiated, so e to the a over a, and because it's the quotient rule, you have to also divide by log a squared. There's not much you can do to simplify this, it's just horrible. So I think I probably would divide this by this and put that as a separate term. Like this. So that's 1 log a to cancel out. But here there's really nothing can cancel out, it's just a horrible expression. And that part there, oops. That means log a squared. That's just a short way of writing this. So that's the final answer. Now let's see if Maple agrees. Minus. That's good. Okay. So I hope you made some progress with those. If you have any questions about these or the solutions, please ask me in the next synchronous session. Next video will move on to some mixed examples where we combine these rules, but for now, thanks for watching.